Hello, everyone. Welcome to our exciting lesson about the evolution of computers. Today, we're going to travel back in time and discover how computers came to be, what makes them so special, and even what they can't do. In this chapter, we're going to explore four main areas. First, we'll learn about the fascinating history of computers, understanding that no single person invented them. Then, we'll dive into the different generations of computers, seeing how they changed over time. After that, we'll discuss the amazing things computers can do, their characteristics, and finally, we'll look at some of their limitations. Here's a fun fact. The computer we know today wasn't invented by just one person. It's the amazing result of many brilliant minds working together over time. Let's begin our journey by looking at the very start of computing history. Since ancient times, people needed ways to count and keep records. Early humans were very clever. They tied knots in ropes and carved marks on clay to keep track of things. They also used simple natural tools like their own fingers and toes, as well as pebbles, stones, sticks, knotted strings, and bones to count. The first big step towards computing was the invention of the abacus. This happened about 3,000 years ago in China. The abacus is a wooden frame with beads on parallel wires, and it's still used today to do simple calculations like addition and subtraction very quickly. In fact, it's even used in schools to help teach the numeral system. Did you know the abacus is still used in schools today to help teach kids about numbers and counting? It's a truly timeless tool. Moving forward in history, brilliant mathematicians started inventing mechanical calculators. In 1642, a mathematician named Blaise Pascal invented the Pascaline adding machine when he was only 19. It's considered the first mechanical calculator and could do addition and subtraction. Before that, in 1617, John Napier invented Napier bones, a device that could perform addition, subtraction, multiplication, and division. Then, in 1672, Gottfried Wilhelm Leibniz expanded on Pascal's ideas and invented the step reckoner, which was the first calculator able to perform all four basic arithmetic operations. The story continues with Charles Babbage, who is famously known as the father of computers. In 1822, he developed the difference engine, a huge steam-driven machine that unfortunately was never fully built. But in 1833, he invented the analytical engine, which was truly groundbreaking. It was the first working model of a mechanical computer, featuring integrated memory, program control, and an arithmetic logic unit, or ALU. His vision was way ahead of his time. Here's a quick fact. Before Pascaline, John Napier created Napier bones in 1617, which was already capable of doing all four basic math operations. As computing machines became more complex, they needed instructions. Lady Ada Lovelace, a brilliant mind, was the first person to introduce the concept of programming for Babbage's analytical engine. She used binary numbers, which are just zeros and ones, to give instructions. That's why she's known as the first computer programmer. Later, in 1890, Herman Hollerith, an army engineer, built an important electromechanical device called the tabulating machine. This machine was excellent at reading and storing data from punched cards. It was so successful that Hollerith started his own company, which later, in 1824, became a big part of what we now know as International Business Machines Corporation, or IBM. Did you know that the very first computer programmer was a woman named Lady Ada Lovelace? That's a super cool fact. After these early machines, computers evolved significantly through what we call generations. The first generation, from the 1940s, included computers like Mark I, ENIAC, and UNIVAC. They were enormous, very expensive, and built using vacuum tubes. ENIAC alone weighed more than 27 tons. Moving to the 1950s, the second generation brought a big change with the use of transistors and magnetic tapes. Transistors made computers smaller, faster, more reliable, and much more energy efficient. Then came the third generation in the 1960s, revolutionized by the invention of ICs allowed many transistors to be placed on a single chip, making computers even smaller, cheaper, and more efficient. These were sometimes called mini-computers. Here's a surprising fact. The ENIAC, one of the first electronic computers, was so huge it weighed over 27 tons and took up a space as big as 1,800 square feet. Next, the fourth generation emerged in the 1970s, bringing us much closer to the computers we use today. This era was defined by very large-scale integration, or VLSI, which led to the invention of the microprocessor. Microprocessors allowed thousands of transistors to fit on a single chip, making computers small enough to sit on an office table. These were often called microcomputers. This generation also saw the rise of hard disks for storing data and the introduction of graphical user interface, or GUI, operating systems, like the first version of Microsoft Windows in 1985. We are now in the fifth generation, which started after 1986 and is still developing. This generation is all about artificial intelligence, or AI. Computers are getting even more powerful, improving in speed, size, cost, and performance. The goal is to develop machines that can understand and respond to natural language, like the chatbots you might use online, or features like autocomplete and spell check. An interesting fact about the fourth generation is that Intel introduced the very first microprocessor, the Intel 4400, in 1971. Now let's talk about what makes computers such powerful tools. They have several amazing characteristics. First, there's speed. A computer can process millions of instructions in just a few seconds. Then there's accuracy, meaning every calculation is performed with a very high degree of correctness. Computers also have diligence. They can work for hours without breaks, getting tired, or bored. Their storage capacity is huge. They can store vast amounts of data on hard disks and other devices. Versatility allows them to perform many different tasks, like typing a document while you listen to music. Thanks to compactness, their size keeps getting smaller. They are highly reliable, meaning they don't make mistakes if you give them correct input. And finally, they have a fantastic power of remembering, able to recall any stored data at any time. Here's a fun fact you might not know. The very first name for Windows, before it became Windows, was actually Interface Manager. Even though computers are amazing, they do have some limitations. Firstly, they have a lack of decision-making ability. Unlike us, computers don't have a brain and can't make choices on their own. They only do what they are told. This also ties into their lack of intelligence. Computers have zero inherent intelligence and only work based on human instructions. They also have a lack of feelings and emotions. Computers are just machines and don't possess human feelings. Another limitation is the time taken in planning and programming. Before a computer can do a job, humans must plan and develop programs, which can take a long time. Finally, there's human dependency. While automated, a computer can't even switch itself on and relies on humans for assistance to start working. It's important to remember that for all their power, computers have zero intelligence on their own. They only do what we tell them. Wow, we've covered a lot today. We journeyed through the incredible history of computers, from simple knots and abacuses all the way to the powerful AI-driven machines of today. We saw how technology leaped forward through 5 different generations, making computers smaller, faster, and smarter. We also learned about all the powerful things computers can do, like their speed and accuracy, and understood their limitations, reminding us that they are tools that still rely on human guidance. Keep exploring the world of technology. One last cool fact: the data you save on a computer can always be recalled whenever you need it. It's like an amazing memory bank. Thank you for joining this exciting lesson on the evolution of computers. I hope you learned a lot and are inspired to discover more about the digital world. See you next time.